I, and DKG sent slides to us that we are uploading as we speak for you all to review. Oh, Ecker sent slides that we're going to review, and we'll go from there. So that's it. I'm not going to go through the working group status of the drafts again because I think we pretty much already know what that is. Oh yes, and we had an open issue about how to deal with gracefully getting rid of SHA-1 in certificates, and we have a presentation on that. And Martin, maybe you go first. All right, cool. Look, I have a slide. Look at that.
There is so much slide here, I'm not even going to bother going up there. That's it. That's all I have.
So the issue here, right, is that we've gotten rid of SHA-1 in the handshake, but everyone wants to like rail at the web PKI and how like SHA-1 is still available. We'd love to get rid of it, but it's not really realistic for us to say it won't work in 1.3. So
yeah, so we have this issue that we sort of closed, where we basically concluded that whatever you said in signature algorithms, well, maybe you could just ignore that. I don't know. And so
we were bowing to reality, right? So it's really like,
well,
we really like you not to do this, but with the must and should language that we use, it makes it a little hard.
So I'm the last person to recommend 6919 section 1 as a tool that we want to use in this context. But the basic choice we have here, so the problem is you got a SHA-1 signature in the chain. How do we ensure that that doesn't hang around indefinitely? How do you signal to the server that you're not willing to accept that? And the suggestion was to use signature algorithms. And since we aren't actually using it for TLS itself, we could sort of just say, well, put in signature algorithms. If SHA-1 isn't there, then it's not cool to have a SHA-1 cert. Otherwise, I guess if it is there, then go for your lives. And at some point, clients can remove their signal of support for SHA-1, and servers would then know that they're not going to make any progress if they have SHA-1 in their cert. Of course, the alternative view that Victor has put out there is that signature algorithms should not dictate the chain that you advertise. The whole business of validating the chain is someone else's problem, and servers just send what they've got anyway, and we should just bow to reality, as Sean pointed out, and stop trying to fix this problem. So that's the two choices we have. I don't know if this is going to reopen that whole kettle of fish. I'll let the chair sort of decide whether it's opened or not.
So it's worth observing that the first proposal would represent a special case for SHA-1, in the sense that the rest of the specification says that if you have, if you don't say you have a SHA-256 certificate and the signature algorithms only says SHA-384, you still send it. So what you're suggesting here is that SHA-1 is a special case, and so SHA-1, if you don't see it, you can't send it no matter what, even if otherwise you would. So I'm not saying it's bad. I'm just saying that is what the implication of this is.
Yeah, I also wanted to point out that I put this out on the list, and there were huge numbers of people saying, yeah, and the Victor said no. That's my read of it. I don't know if there's anyone willing to speak for Victor at this point in time, but I'd like for someone to do that so that we can at least have a discussion.
So I do believe actually Victor would be satisfied if the restriction did not apply to self-signed certs, or to search a trust anchor. So you're not going to validate actually.
Yeah, Rich Sauls. I think Victor was concerned about new existing programs dropping in a new library, and then all of a sudden their existing cert authentic authorization chains failed. Just realized that can be solved by making sure you install a version of the library that changes what the default behavior is to always send, the new extension, so that You can be insecure by default with absolutely no software change, just the way you install the library. So you lose. Just go ahead and do it.
Yeah. So Martin Thompson again. I think the point about trust anchors is a good one, and probably should look at addressing that. We have trust anchors in the Firefox Trust Store that have MD5 signatures on them. They're really just containers for keys when it comes right down to it. It doesn't really matter much what they say. So I think we have fingerprints from them in certain places so that you can check that the whole thing has integrity. But otherwise, it's just for the purposes of chain validation, it's just a container for a public key. And same applies to trust anchors in general. And if you're doing self-signed certs, then you're going to be using some other way of working out whether you trust that particular cert. So having some sort of text in there that covers that would be nice, because I think we could exempt all trust anchors from all of these requirements on that basis. Of course, it's different for self-signed certs because there's this expectation that you're going to send a self-signed cert, whereas usually you don't send a trust anchor, but they are both trust anchors in a sense. So if we look at it that way, we can sort of maybe weasel out of it somehow.
Russ Housley, I have to disagree with what Martin just said. The self-signed cert is a convenient way to distribute the trust anchor's public key and its name. You have to know its name because it's the issuer in the next cert down in the chain. But the signature on that self-signed cert is not important. And that's what I think we ought to just be focusing on and say, it doesn't matter what signature is used in the self-signed cert, which is a convenient way of distributing a trust anchor, and the chain terminates there, and don't even look at what signature was on that self-signed cert.
So I think Russ's suggestion there was pretty solid. I like that.
So
the suggestion was that the signature on a trust anchor or a self-signed cert was not important.
right.
You don't check it. Therefore, it doesn't matter what algorithm it uses. It could use ROT13 signing, whatever that is. Please submit that draft. I will lobby for having a ROT13 signature draft go through ISE or something.
So how about this? For this approach of the first approach here of use signature algorithms, if we add this text about self-signed cert signature not being important, so it doesn't matter, doesn't figure in.
It's not part of the path.
Right. Yeah. Does anybody object to that approach? Using the signature algorithms field. Is anybody in favor of that approach?
How do you want to be a hum now?
Oh, yeah, sure. Hum now. Okay. And so we'll just do does anybody object to this approach? Hum now. All right. Uh-oh.
Yeah. But then, according to Pete's protocol, it should be called to the mic. I kind of object to protocol documents making requirements about how the same client should act when it is in the role of a relying party. As a relying party, the client can decide that it doesn't trust SHA-1 signatures or MD5 signatures. And that should be separate from whatever signatures the client accepts within a certificate verified.
So this isn't rule about the client, it's rule about the server. Is that the server should not refuse to serve self-signed certificates that have SHA-1 signatures. There's not a rule about the client. The client can still do whatever it wants.
Well, yeah, but we're telling the server not to send such certificates on the assumption that the client won't accept them. Because if the client is fine with this certificate, then there's no reason for the server not to send it. We're using the signature algorithms in the client hello as an indication of what algorithms the client is going to accept in certificates as well in certificate verify. And I think that's a wrong approach, but I feel that everybody else is okay with it. So no, it's an indicator for what algorithms are going to accept in the certificate verify. The certificate itself could be a GOT certificate as long as it has a proper algorithm in the public key.
Yeah, so Martin Thompson, off mic, Eka is saying the whole point of signature algorithms is to specify what signature algorithms you support. But Yoav has pointed out that there are multiple places where signature algorithms are used. Some in the chain, some in the protocol itself. I'm personally perfectly comfortable in conflating the two of them. I get the sense that a number of people are, and some few people are not. So that is why we have this consensus process.
To be clear, this has been the semantics of this extension since TLS 1.2, since 246, and that we had consensus to relax those semantics slightly to say that you could send non-conformant things if you can non-conformant things if and only if you couldn't send the conformant thing. But like this has been the, I mean, we're not even talking. We're talking about all we're talking about here is removing that exception for this one case.
Yeah, what he said.
Yeah, so I think we'll have to have a text proposal, and we can, you know, I think we'll we'll have rough consensus in the room. We'll probably have to talk it out on the list too, but I think we're on the right path.
So now we're going to talk about again about encrypted SNI. So this is like hour 27 at this point on this topic. So
yeah, but yeah, it's worth it. It's awesome. All right, disclaimer. Yeah, so the pointers here that I'm going to describe need more analysis. I'm hoping that by describing them, I can encourage you to give them analysis and get feedback, either in the room or on the list, or both. So next slide, please. So, okay. Okay, so without looking at that slide right now, the scenario we're looking at is we'd like to have a client that connects to a TLS service be able to provide its SNI in such a way that the network attacker can't tell what the name of the host is, right? So the obvious attack is that the sensor looks and says, oh, you're going to ecker.github.com. That's obviously a criminal, but maybe you could have been going to kittenwar.github.com, and that would not be a criminal. It might be the same name, it might be different names, but you'd like to be able to provide the actual name only to the server that you're talking to, and not allow a network traffic to interfere with it. So when we're talking about these, it's worthwhile to think about the scenario that you have the client and you have the origin that they want to talk to, and that the origin and that you have a third party that may be called, we'll call it the gateway or the cover, that provides this other identity that the network traffic, someone who's monitoring the network can think is what you're doing. So this is not something that's going to be on by default. It's something that's going to be optional, and there will have to probably be a relationship between the cover, the gateway, and the origin server in order for this to work, and the client will know about this relationship. So that's the sort of architecture that we're talking about. And so if the client is connecting to the origin without using the cover, the client would like to be able to figure out that a cover is available for this particular site. So if I visit if I visit ecker.github.com, then the server and I expose myself to the network once that I'm going there, and I do go there, then ecker.github.com can say, oh, by the way, if you prefer, you can visit kittenwar.github.com. You can say you're visiting kittenwar.github.com to the network, but you can still reach me. If you connect to so in that case, kittenwar is the cover. If you connect to the cover, then you can't tell just because you connected to the cover that anybody is behind it, right? So you can't say to the cover, give me a list of all of the sites that you're covering for, because that would be problematic, because then a censor or someone who wants to surveil who's visiting bad stuff could just go to any arbitrary site and say, hey, who are you covering for? And then they could use that to figure out what everybody else is doing. On the other hand, given that the client basically needs to be able to say to the gateway that they're going to somewhere, that they're actually using a different site, anybody could be that client. So you sort of expect that anyone, including a network adversary, could probe and say, do you cover for X? And the gateway would be able to say, yes, I cover for X, or it would end up validating. So that's hard. That's something that we're not trying to defend against. Right. So anybody who's looking at the traffic shouldn't be able to tell that the traffic is different, whether it's covered traffic for the hidden server or whether it's actual traffic to the cover. And we're not going to solve the problem of fixing the initial connection to the origin. Either you try it once on a safe network and now you can go to an unsafe network, or we have some other way that's out of band that I'm going to totally ignore. Does that context make sense?
On point number 2, are you saying you can tell it's covering for somebody, or you can tell it's covering for a specific somebody?
No. So what you want that when you connect to, as a client, if I connect to a site, I can't say, do you cover for anyone? But I can say, hey, if you cover for X, let me through to X.
In point 4, it says hidden server need not be protected. Do you mean it cannot be protected, or do you actually mean that there's no need?
With this proposal,
cannot protect it.
Does not protect the initial connection to the hidden server.
Okay.
In TLS. Now maybe there's some other non-TLS way that the information can be passed.
So more properly, the way to think about this is this proposal depends on having some priming information about how to interact with the covering site, and that you have to learn that priming information somehow. And if you have some out-of-band way of learning it, then you're fine. But otherwise, you only get it by connecting to the site and having it tell you. And that's the best way. And that's the only thing we know how to do. I mean, the bottom line is you're going to be connecting to this guy. You need to know who the cover is, or it doesn't work, unless everybody's a cover.
Right.
So, yeah.
There's more slides to go through, but if Jenna, Martin.
Jenna, so when you say the covering site, is that actually something like hidden one? Is that an ASCII? Is that a regular SNI like everything else? Just a hidden one?
Yeah. So the reason that let me walk through it a bit. The reason that we're treating cover as though it was a regular site is because this is not going to be on by default, and as a result, every TLS handshake is going to have an SNI in it. Right. And so a network observer is going to be looking for this SNI as it goes across. And so it better be plausible, because if it's an implausible SNI, then the network attacker can just cut off anything that has an implausible SNI. So you need to think about your...
Right, but okay,
yeah.
I'll wait.
So that's why. So next slide, please. So this slide is wrong because I haven't fixed it. There's actually 2 modes. The top 2 are basically actually the same scenario, right? So there's a simple scenario which is covered by the top 2 of those, which is where there's like in the GitHub example, that's actually probably a simple scenario. Think about a wildcard cert, right? The cert identifies multiple domains, and you get to choose, and some of them are dangerous to visit, and some of them are not dangerous to visit. And so the not dangerous ones are the ones that you would use as your cover, and the dangerous ones are the ones that you're trying to actually visit. So that scenario is simple. In that scenario, you either decide to omit SNI or there's two options. So first off, you need to be able to say, here's my SNI within the encrypted part of the client hello. And then you have two options for the SNI. You need to either omit the SNI entirely, which potentially identifies you as someone who's doing something unusual, or you need to be able to choose an SNI to expose there. That's the top two options. They're actually the same scenario, and I don't believe the bullet there. I just didn't have a chance to fix it before the slides. Sorry. Yeah, I don't think they're different anymore. Okay. So the tricky part is this scenario where you say, look, I want to have a gateway arrangement. The hidden service says, I'm going to make an arrangement with a gateway, with a cover server that's going to act as a gateway. And the cover server provides other websites that are legitimate, but they shouldn't get access to my traffic just because they're acting as my cover. Right? The simpler scenario, it's the same server that's doing the operation. It gets access to all of the traffic. But if you're a sensitive site, you may want to say, look, I'm happy to get cover from the New York Times, but I don't really want the New York Times to see all the information that flows through the HTTP connection. So that's the slightly more tricky one that requires a little bit more than just an SNI to know what to put in on an encrypted SNI. So I want to just make sure that people understand, if you wanted to do this with the encrypted SNI in one of those top two cases, that all we need for that is an encrypted client extension that just says SNI for real. Does that seem plausible to folks? Right, so I have my external SNI, it says New York Times, and my internal SNI says ecker.github.com.
So Martin Thompson, as a practical matter, you have to have some expectation that the server understands this, right?
Yes. Well, it's an extension. It's an extension.
It's an extension. And we got an encrypted extension in the 0RTT flight, right?
What's that? Yeah, it's an encrypted extension in the 0RTT flight. I'm going to show
and you're going to end up in a situation if it's not supported where the server's going to route you back to the cover.
Yeah,
the server has to know.
Yeah.
And if you are mistaken in your belief that the cover is actually actively covering for anyone, then you will end up going to the cover.
Yes.
Yes, that's correct.
Yeah, that's right.
All three parties need to be aware of this arrangement.
Right. So, and more specifically, what will happen is that what will happen in the first. The reason I try to distinguish these cases, in the first case, what will happen? Actually, the first case, it may simply work, right? In the first case, you'll get a star certificate, and if they only route an HTTP host header, you're like, actually, be totally fine. In the second case, that happens all the time.
The cases are the same,
right? But no.
In both cases, the certificate that you get is valid for either the cover or
no. That is the point. That is exactly the point. The point is that in the first point, every certificate. The domain has the server has exactly one certificate that's valid for every domain it hosts.
That's the same as a SAN certificate.
No, because many servers actually have a very large set of certificates, and they have a series of certificates that only cover sub-portions of the space, and depending on the SNI, they send you different ones. And so in the first case, what will happen is it may in fact totally stinking work. In the second case, what may happen is you may get the wrong certificate, and then you will get a validation error. That's why they're different cases.
Let's look at the flow. Let's look at the flow.
So yeah, so sorry. Let me take it back. They're different because I was misreading what that one was. You just skipped ahead of the. But yeah, let's skip to this. Do you guys mind if we move to actually looking at some flows first? Do you have points that need to be held? Yeah. Sorry. Go to the. So this is the co-tenanted flow, right? Where it's the same machine that's operating both the cover and the sensitive site, the cover and the hidden site, and there's no attempt to protect information between the two realms. So in this case, we just send our innocuous.example.com. That's our cover, and then in the encrypted extensions, we send our real SNI. The hidden server responds, and it responds with a certificate, and the certificate is for hidden.example.com, right? And now, in the event that that the hidden server has multiple certificates and multiple secret keys, it needs to know the certificate to send back down here, but it needs to be able to decrypt the client's extensions based on the certificate that belongs to innocuous.example.com. The certificate. There's the server config and the certificate that are digested in order to get the handshake keys in order to be able to decrypt the encrypted extensions in the client hello.
Yeah, so more precisely, the hidden server as well as potential gateway. Both
these are co-tenanted. There's no gateway in this model. We'll get to the gateway.
In either case,
no gateway.
In either case, they need to know what certificate relates to that server configuration, which will be the cover, probably. Yes.
The certificate that's involved here is
whatever keys are associated with that server configuration, so that they can decrypt that 0RTT flight and work out which cert to send.
That's right. But the certificate that's sent back is a certificate of the hidden server.
Why do we need the hidden SNI? I mean, it's the same server, and
it's the same server, but
yes.
in the case where the server has multiple secret keys and multiple certificates, then the client needs to be able to actually validate that this is hidden.example.com and not innocuous.example.com.
The client has early data that that innocuous and hidden are the same machine. So the innocuous certificate should be good enough.
No, the client's not going to distinguish between this case and the gateway case. The point here is to design one mechanism that works for both of them, and the server operator can decide. But we're not going to have two separate mechanisms here. But the key point here is that the certificate that's used to calculate the handshake keys in order to decrypt the encrypted extensions belongs to the cover, and the certificate that's sent back belongs to the hidden server. And the signature over that certificate comes from the hidden server signature, right? That's a hidden server.
So I think I want to let you move on, but I want to nitpick this very slightly, just so people have in their heads. It is not necessarily the case that it's desirable not to the client be able to distinguish the case following. And the reason is because that the client would like to be able to send 0RTT data, and in the case following, the client cannot send 0RTT data, and in this case, it would be okay if the client could. And so
it may be that this arrangement, in order to avoid adding additional fiddly bits, you're a hidden service. That means you don't get to do
right. So that may be the most desirable set of arrangements. I'm merely saying that in principle, this system can be made to work while still doing 0RTT, whereas the other topology cannot. Yeah, that is
yes.
The other version hijacks 0RTT to carry.
So let's get to that, and then we can.
Can I? So in this case, does innocuousexample.com can read the early data, right?
This is the same server. The same server is doing all of this operation. So yes.
So even right. Okay.
I mean, it is the same server in this scenario. So let's look at the next flow, and then we can reason about it a little bit more clearly. Right. So that's just so here's this flow. Some of these arrows should go further across, but I don't know my LaTeX well enough to get them there. So I'll point to the ones that are. Do we have a little laser thing so I can shoot Ecker in the eye? Okay, so the same flow from the client, right? These come through to the gateway. The gateway can decrypt this. So the gateway gets the encrypted extensions, decrypts it, and says, "Oh, this is going to this other server that I actually have a relationship with already, that I'm offering cover for. I don't want to be responsible for being able to see any of the traffic that goes through, but I do know that it goes to this hidden server. So I'm going to take this flight here, and I'm going to just bump it over to the hidden server. And via some other mechanism that might be a separate established relationship between the cover and the hidden server, I'll make sure that they're able to actually decrypt this encrypted extensions. This has it in the clear here to indicate that this guy won't be able to do that decryption. So the hidden server gets this based on its relationship with the gateway, and then turns around and sends back a server hello, and it's encrypted. And these are the arrows that really should go all the way through to the client. The gateway at this point is actually just doing opaque traffic forwarding once it's done its initial decryption and send out.
Yeah, Martin Thompson, I'm looking at this and wondering why you don't just send the encrypted extensions all the way through. Why not? Why?
So the other side, I think what you're sending through is encrypted extensions, but the gateway needs to give some additional information as to how to actually decrypt it, because the hidden server doesn't know the server config for the one time, right? The gateway has
So what is the purpose of doing that? The nice thing about the very nice thing about this about the design of zero-RT in this case is that if you're doing failed zero-RT, it bears no relationship with the handshake. You simply skip over it. So if you want to send encrypted extensions merely to have garbage for the server's algorithm to skip over, then fine. But the entire point is that since there's no relationship between, can you reload the slides? There's no relationship between the zero-RT flight, which is being consumed by the gateway, and the rest of the handshake is being consumed by the terminal server. That data is simply unnecessary and doesn't need to be consumed at all.
Yeah, there we go. Thank you.
Okay, what?
Well, let me explain. This forces the hidden server to have exactly one certificate.
No, it doesn't. The hidden servers. So
how does it know to switch between hidden 2 and hidden 3?
It does that the same time. This is not actually involved in any of the early handshake stuff. This certificate that comes back is related to the key.
Likewise. Okay, good.
Your position has the impact that this is not a standard TLS handshake between the client and the hidden server. It absolutely does. If you simply do it this way, then the only thing that's happened is that the hidden server can simply behave like any other TLS server and simply ignore the failed zero-RT handshake. If we do as you suggest, then it has to have special case logic to process the dummy encrypted extensions, which is not encrypted with any key it recognizes.
So
okay. I understand why you might argue that sharing the keys between the gateway and the hidden server is undesirable, but yeah,
right.
There's also, by the way, the zero-RT key, which if you don't do that, if you do in fact share the keys between the gateway and the hidden server, then anybody compromise the hidden server can then determine whether things are covered traffic for everybody else.
So
that's no different to the co-locator.
There's two keys that are involved here, right? There's the secret key that's held by the cover server that corresponds to the server config that's in use in this zero-RTT case.
Right. And that's one key. And that cannot be provided to the hidden server.
The hidden server doesn't know it, and the cover server wouldn't want to give it to the hidden server, because then the hidden server could decrypt traffic that was zero-RTT traffic that was sent.
As well as decrypting.
And then there's a key. Then there's the long-term identity key of the hidden server, that the secret key of which is not shared with the cover server.
Right. Not just zero-RTT data, by the way, but also encrypted SNIs.
Right. Well, that's zero-RTT data.
That's convincing.
Clarification question. And maybe this is what Martin was saying, but the SNI that's going from the gateway to the hidden server, is that supposed to be innocuous? Yeah. And it's not supposed to be hidden.
That's the cost, right? The cost of this design from this perspective, unless you have a side channel, is that the hidden server does not learn the true SNI, so it just has to assume that the SNI is basically it's SNI-less. And so the hidden server, and so if you want to have the hidden server wants to switch it, you have to IP switch it, or you have to have a side channel.
So
Or as you say, you can forward the encrypted extensions and allow the hidden server to simply ignore it. So I think you're correct to say that the client should,
no, you can't have the hidden server ignore the encrypted extensions because it needs this in order to calculate the session hash, the handshake hash.
No.
It needs the hidden server needs the clear text of the encrypted extensions.
No. I understand, but what I'm saying, no, it doesn't need the clear text of the encrypted extensions.
How does it calculate the handshake
It's
hash?
that's not part of the session hash. The session hash does not, and it has to not be part of the session hash because from the perspective of because it has to not be part of the session hash because otherwise failed one or two handshakes don't work properly. I mean, this
right.
the thing is, this looks like
okay.
this. I mean, like, what's actually irritating about this is the thing that's actually irritating about this is so with the server. And this is a mistake in this slide, by the way. The server is supposed to claim that it's not doing 0RTT. So the hidden server should actually say the hidden server should pretend that this is actually a failed 0RTT handshake. Or we should put early data indication in the cipher. I mean that the point is that the client with the I mean this is because 0RTT and 1RTT are separated, right? And 0RTT is like an email. It doesn't matter whether you process for the rest of the handshake. It doesn't matter whether you process 0RTT data.
So I actually don't. Sorry, I'm going to take that back. I don't think that that we can have the hidden server treat this as a failed 0RTT. Because the result of that is that it will send back the message that would come back through would be a pointer to a new server config. And the server config needs to stay the same between the client and the gateway.
No, I mean, I'm assuming the hidden server always sends back a server config that corresponds to the cover.
Okay.
So, and besides, that's an orthogonal question to which you send to whether it's a failed or successful 0RTT handshake. The failed versus successful 0RTT handshake only is I consumed this data or I threw it away. And so I mean, the point I'm making is if you, as Martin suggests, take those encrypted extensions and give them to the server in ciphertext, not in plain text, right? Then the server can simply skip past them the way it ordinarily would, and it operates exactly the same algorithm that it would be operating with a 1RTT handshake with a server config it had never heard of. A 0RTT handshake it had never heard of, right?
Right.
And the only irritating part is that now it sends back to the client an indication that says I threw away this early data. Which is in fact kind of true, even though the gateway processed it. So the gateway assimilates the early data, he throws it away. He basically doesn't give it to the server, and the server says, I didn't get it, I ignored it, right?
That's right. Right.
Stephen Farrell, so just can you clarify, because it's kind of late and I'm slow, what secrets are shared between the gateway and the hidden server?
There is no secret directly shared between the gateway and the hidden server. What there is there's an established relationship between the two so that the gateway knows that it should forward things on if it gets encrypted SNI to the back end. And the backend server knows that when it receives messages from the gateway that have the gateway's SNI in it, that it should go ahead and process them in this fashion.
So does that mean
so there's an established relationship that's not in TLS?
So can a gateway act on behalf of many hidden servers?
Yes.
Yes.
Arbitrarily many.
Okay. Yeah. So how does it know which one to send to?
By decrypting this this encrypted extension that's a real SNI that's sent in the early data.
And there's no secret needed to share between the gateway and the hidden server.
That's correct.
So the hidden server can't decrypt the bottom half of that first message to him.
Correct.
That's correct.
So he can't decrypt early data. He can't decrypt any kind of encrypted extensions. He can't decrypt any of that.
That's correct. Yeah.
So all he sees is the original client hello to the innocuous.
Correct. And some noise.
That's right. And a bundle of noise.
Oh, okay. So all right.
So can I try to
use your little red thing to highlight the noise?
No.
So that's
it's not there.
So then what does that hidden server do at that point?
it sends the one RTT handshake.
Back to the original client.
Yep.
And then what does the client do?
Yeah,
So
it just happens.
he's assuming that he's now talking to the hidden server using his original first half of his handshake.
Right. So the client knows because it gets the certificate that validates the hidden server's identity. Right. This certificate is a certificate for hidden.example.com, and this is an encrypted certificate.
Yeah, okay, so the server hello that comes back says, hey, I'm turning down your 0 RTT. Here's my second half of my 1 RTT exchange with the certificate.
Yeah, sorry, I do think that, yeah, I think these slides are causing us some confusion here, and I do actually think there does have to be a secret shared between the gateway and the.
So honestly, can you start with a 1 RTT case?
No, there is only a
There is no 1
RTT.
RTT. We're basically abusing 0 RTT in order to get this to happen in a data flow that happens
Okay.
elsewhere.
So the 1 RTT case, if I'm following correctly, is the client would connect directly to the hidden server. Is that?
No, well,
Because it
he doesn't
know
have a
there's
1
gateway.
RTT case. He only has a 0 RTT case.
I mean, it's not actual 0 RTT in the sense that the client is not actually sending any data in the
Right.
0 RTT.
Right.
To a
it
network
looks like-
observer, it looks like a 0 RTT. A network observer here, it looks like a 0 RTT connection to the gateway.
Mhm.
And, sorry? So,
Yeah, so we're getting the microphone queue is getting a little out of control right now. So
Yeah.
let's go Joe, and then
Just one
Martin,
question
and
for
then-
what's the client key share that where does the hidden server get the client key share from?
In the client hello.
So no, but this is the question, right? The question here is what, like, this needs to come back with this. This is a client hello that's going to look like to this network that's coming from the gateway. And it's going to include some information that is encrypted in the remaining encrypted stuff with the handshake key.
I'm going to summarize this if we're all done.
All right, Martin,
I'd like
go
to
for it.
summarize what the changes you're proposing are, because I think everyone's got a bunch of questions, and I think I've sorted it out in my head. Martin Thompson. Sorry, Jim. The client has to understand that some gateway, some innocuous site is playing cover for some hidden site that it wants
Yes,
to.
right.
And it needs to understand. It needs to somehow elicit a server configuration for that cover.
Yes, we haven't gotten into elicitation of the server configuration.
Maybe it just connects to the cover and finds it. I don't know. There's a bunch of options later in the slide deck, I'm sure. Then it conducts a normal handshake, but adds an encrypted extension in its 0 RTT flight that says this is the one I really want.
That's correct.
Right. That's all the client really needs to do. It does need to identify the fact that the server configuration doesn't allow for data, because if it has early data allowed in it, then it's probably
right. You don't want
not a good cover in that case.
Right. You don't want to
Probably a bad
supply
cover in that case.
That is. Well,
You don't want to put actual stuff
the
in
client
in
doesn't
that
want to
0
put
RTT
actual
flight.
stuff in there.
Right.
Whether the server config allows for actual stuff or not is fine. It should allow for stuff. Yes, it must allow for stuff, but the client.
Oh, yes, because you're going to pad this stuff so that it looks like you're actually exercising 0 RTT.
Exactly. Right.
Exactly. Right. The gateway simply needs to understand the configuration that we're talking about.
Right. And its relationship with the hidden server.
It then needs to parse the encrypted extensions, look at the real SNI and replace that.
That's correct.
Like clobber the SNI that appeared in the clear. That's all it really has, and then just route to the from its perspective, from its routing perspective. Use it for routing.
Use it for routing, right?
Yep. No touching of the client hello. And then once it's done that, it just forwards the entire handshake to the back end. It's got no more responsibilities.
That's correct.
Case. The hidden server just needs to ignore SNI. That's all it needs to do in order to get this to work. And use the server configuration for the gateway when asked for one.
when calculating the handshake keys.
Just when calculating the handshake keys and all that. Well, actually, no, it doesn't need that.
We need to know the server certificate in order to calculate the handshake keys.
It needs to know this server certificate. The handshake keys? Yeah, part of the handshake.
So
because
Stephen Farrell, I think that the hidden server also needs to ignore the crap octets it can't decrypt,
That
right?
just happens by default.
That's just normal. I'm
normal?
talking
Okay.
about the delta on top of TLS-13 normal.
It's already the case that when you don't know the server config, you have to. If you don't know the server config, you don't know the Diffie-Hellman key, and then you're basically stuck because you have to throw stuff away, right?
So to be clear, the delta on top of TLS 1.3 for everything we've talked about so far is an extension called real SNI.
Well, I mean that's quasi true, but like there's a lot. That's the actual wire protocol changes.
That's the wire protocol change.
So
yeah.
I mean, so it's really true that in the previous like 2 slides, that's really the change, right? Because really you're talking to the same guy, and all you're doing is giving him a hint of the right SNI. And there's no new semantics. I mean, the semantics are always the same. You're talking to one person. This is different, and the semantics are now split. You're saying half your stuff to one guy and half the stuff to the other. So they are semantically quite different, even though the wire protocol is exactly the same. And I mean, the wire protocol has to be the same, otherwise it's not distinguishable. It's distinguishable, but I mean, just could we like, are you abusing the bits in different ways doesn't mean that like it's the same semantics.
All right. So back mic too. Sorry.
Yeah.
Okay, can you just clarify one thing? Obviously, there's a TCP connection from client to gateway. There's a connection from gateway to the hidden server. Is the gateway then stuck forwarding data for the hidden server forever after on that connection?
Yes.
Okay, that's a big job for the gateway to sign up for.
Well, the gateway, I mean, this may actually be one machine that has multiple, like, otherwise
it's the same machine,
protected
great,
domains. But yeah, if a gateway decides to do this forwarding, then yes, and it's a machine that's like off net, off the same network. Yes, it will be doing that.
All right, Rich, you got there first. Do you want to pass up? All right, okay. Yes.
Jana, I don't think it has to be, but that's a matter of how the network there can be architected between the gateway and the hidden server. There can be forwarding that's done in the infrastructure. The load balancer knows to ship these packets out to the hidden server directly instead of shipping to the gateway.
Right, as long as the 4 tuples been identified, the 2 4 tuples have been identified and linked. It doesn't need to be the web server handling that at that point.
That's right.
Yeah, you could implement that.
Yeah, you could do that. Clarification question, and I am slow on this, but what keys are used to encrypt the initial data that's sent from the client? What is the key that's used?
So there's a handshake key that's established for 0 RTT data, and it comes from the client's ephemeral secret.
Yes.
Combined with the server's the public key from the server config.
Yes.
That is the server config for the gateway.
Can it be the server config from the hidden server? In that case, why not?
Because the server config ID is shared on the network, like the server config ID is visible. So you'd have to have the same server config ID, and then the gateway itself has to be able to decrypt the real SNI. And the only way that it can do the decryption is by looking at the server config ID. And if the server config IDs are identical, then that's the only thing.
I was talking about simply the data, the initial data that's being sent from the client, because the gateway is not going to look at that anyways.
Which data? The application data down here is
the application data. Yeah.
Application data is not protected by the handshake keys at all. Application data, right? Our key schedules change between the handshake and the application.
There's no application data on this slide.
Yeah, there is no application data on the side. Yeah, that's true.
You end up with it ends up with a 1 RTT handshake for the actual data that's being transferred.
Okay, I guess I'm thinking about why it is that the data cannot be sent before the server hello is sent with an initial key that's used from the hidden server config if the client has already spoken to the hidden server before.
Because the client knows that this is actually just acting as cover and doesn't want to share the content of its request with the cover.
No.
Okay, let me try to explain this because I think maybe it'll help. The inherent logic of the situation, right, is there need to be, if in this topology, there need to be 2 sets of keys. One set of keys which is used to encipher the gateway, and one set of keys which is used to encipher the hidden server. So the observation here, stupid though it may be, is that there already are 2 sets of keys when you're doing 0 RTT, the ones used for 0 RTT and the ones used for 1 RTT. And so the hack here is to say, well, we're going to abuse the 0 RTT keys to pass the encrypted SNI, and we're going to use the 1 RTT keys for the data, right? And so in order to do what you're suggesting, you need a 3rd set of keys, which would be the 0 RTT keys that you need to talk to the hidden server, and that would involve changing the protocol line. And so now the question is, like, like, so, I mean, so the
I don't
idea,
want to change the wire protocol if we can help it.
right. I mean, so the point is like I mean, this may be a whole, I mean, like, that's why I made DKG put this disclaimer at the front, right? But that would be a big change to the protocol to support that.
I suppose so. I was trying to figure out if the RSNI is if the gateway knows what to do when it sees an RSNI, it can also know what to do when it sees data with the initial handshake.
But the data that comes in with the initial handshake, it shouldn't be able to decrypt it.
No,
right?
it should not be able to decrypt.
So you're suggesting that you could encrypt the non-SNI stuff with additional information.
The non-SNI stuff with a key from the hidden server config. Again, if you have that server config,
Right.
catch to the client as well. You have to server configs. Yes, correct.
So you could also say, well, there's an encrypted extension.
Well, you could. I mean, it's recursive ultimately. Yeah, but certainly.
But I'd rather. I'm trying to make sure that we understand that just the encrypted, just the real SNI extension will.
All right. So we got 10 minutes. Back, Mike.
I guess there's a problem on the flows if there's a NAT between the client and the hidden server regarding the server hello message.
I'm sorry, I didn't understand. Can you say that again?
Eat the microphone.
If you have a NAT between the client and the hidden server.
A NAT?
Yeah.
So, yeah, no, but a NAT is acting. I don't think that NAT, I don't think we're talking about the IP layer here at all. And I think of NATs as acting at the IP layer. So I'm not sure what the question is.
I actually had the same comment because I think he may have an issue here. You send, depending on how the packet looks like, so initially the client addresses the packet to the gateway and will have those IP addresses.
So the client is still sending packets to the gateway. The fact that this goes all the way through, it's being relayed through the gateway just as a raw TCP payload.
That's
sorry,
understood.
Yes. So, but the point is that the gateway has no access to the content of any of this stuff. That's the reason why they go all the way through.
All right, middle mic. That's you.
Kyle Rose. So I can't remember what all of the assumptions were on the original slide, but two things. The first, it doesn't appear that the hidden server can itself do SNI. So it needs to know what certificate to serve up immediately. Okay. And the second thing is we're assuming that there's no traffic analysis between the gateway and the hidden server, correct? Because otherwise they could just see that the same data is being
That's correct.
relayed.
Right. I mean, you could do a timing attack on this if you have if you can monitor all the traffic coming out the gateway.
Okay,
for sure. So either the hidden server can't do SNI, or you have some additional side channel between the gateway and the hidden server that we're not specifying here as part of TLS.
All right, Deb.
So wouldn't it be simpler to do a tunnel within a tunnel here? So wouldn't it be simpler to establish a tunnel with the gateway and then establish a tunnel within that tunnel to the hidden server?
Well.
Oh, sorry. Deb Cooley, NSA. I'm not wearing my badge either, sorry.
So it depends on what kind of simpler you mean, right? Whether you want the gateway to be involved in decrypting traffic as it goes through, or just forwarding the
So
frames.
the gateway is involved in decrypting traffic, the outer tunnel to it, right?
Not here, no.
No, not here. Not in my suggestion, it would be.
In your
So in
suggestion,
my suggestion, you would do a straight up regular connection to the gateway, establish a TLS tunnel, and then establish a tunnel through that to the hidden server.
but now you're expecting the gateway to be able to continue to do all of the cryptographic
Well,
operations.
you're
as it
already
hands
pushing
stuff
all
off.
your data through that gateway anyway. You're just making it decrypt the tunnel.
But then you wouldn't be able to like hand off to your network-based load balancer and say, hey, packets that are coming in that look like this, send like packets coming in from this 4 tuple, send them out via this 4 tuple.
Okay, why
Right?
not?
Because you have to actually decrypt them to send out
Sure.
the inner
Well,
tunnel.
you're going to decrypt the tunnel you've established with the gateway.
Yes.
So you're
The
going to come in.
the gateway is not doing any decryption beyond this bundle here. In this arrangement, the gateway is just reduced to forwarding layer 3
Okay, so you think
packets
that's
here.
a lot of work for the gateway to decrypt the traffic?
I think it would be easier to ask a gateway to forward packets from a given connection than to do
Than to
decryption for
decrypt
giving.
and forward.
Yeah, in terms of if you're a hidden service and you want to ask somebody to cover for you, it's a lighter ask to ask them to do this initial decryption and then forward packets than it is to ask them to do continuous decryption.
Okay.
Chennai or DKG, I think you should really say that it's possible to for the gateway to get out after the handshake, because it can get out of the way completely.
With this design, but not with Dev's.
Right.
Yeah, with your
Right.
design, it can get out of the way, and I think you should actually
Right.
not say that it has to forward packets, because it's entirely possible. It's entirely reasonable to expect network load balancers to actually manage this.
Okay.
So I confess to actually being fairly persuaded by the point Dev just made. So it seems to me that there are essentially there are essentially two major situations. One is the sort of default setting where I just want to host my thing on App Engine or GitHub or whatever, and all I want to do is hide the crowd there, and I trust those guys because I basically was hosting on GitHub anyway. And so all I'm trying to do is hide that, and we can get that, and that's gonna be a lot of people, and we can get that with essentially no violence to the protocol whatsoever, and no complicated reasoning about the world whatsoever. And then we have the system where it's a much more complicated system, which is kind of making people's heads hurt, and where I have much more stringent security requirements, and where and I don't trust this guy, but I'm gonna make this guy jump through a bunch of contortions anyway, so I feel like in those circumstances, like I'm willing to ask that guy to decrypt as well. And so, I'm starting to think that's where we should cut this and say, look, like supporting the co-tenant case is worth doing, and supporting the gateway case of special TLS logic is not worth doing, because all we're really optimizing for is him not having to forward the packets and decrypt.
Hi, Rich Sauls, Akamai. So I think this is sort of backwards comment from what we usually hear. I think the technique is really good and appropriate, and it doesn't change any of the protocol flows, which has, I think, been the problem that's killed encrypted SNI all the time we've looked at it in the past. I think frankly, the slides in the presentation have done a real disservice and made it sound a little more complicated and muddied than it really is. The other thing that's missing is the real understanding that there's a lot of stuff that happens outside the protocol here, and we're not trying. Whereas before we were always worried about how we get the key, how we get the key shares and how we pass along the SNI without giving away the fact that we're passing along the SNI. And this is the minimal set of things that the protocol has to do to enable a privacy preserving through connection. In this case, in some cases gives the cover some deniability, maybe not complete, and also allows passive observers on the outside to not know that this is going on, leveraging other aspects of the protocol. So it's kind of weird, but the protocol flows stay the same. There's one little, like you said, there's one little bit that's different. And maybe seeing it written out in some better diagrams would help people feel more comfortable with it. But I do think we should do this.
Ian Sweat from Google. So to push back on Eric a little bit, this is totally complex sounding, and I can't say I actually think that I have an obvious use case for the second gateway server flow. So I'm kind of totally happy to not have it from kind of a personal perspective. But when I think about it, it seems like either way, as you said, on the wire, the only change is the RSNI, and you need that for both flows. And so this seems like a total optional implementation that someone could implement if they wanted to and actually cared about, and would not necessarily need to be in a standard SSL implementation. And so I guess I see no reason why you couldn't use this as an illustrative case, but I have no expectation that like OpenSSL or something is going to support any craziness like this. So.
I mean, I'll provide patches for OpenSSL to support it.
So might as well do it because I see no cost to myself, but possibly I'm not being nice.
Again, the gateway has to opt into this anyway, right? I mean, these relationships have to be established.
Yeah, clearly everyone involved has to kind of know about this clever little dance that they have to do, which is totally clever. Like, I mean, you could chain these as many as you want. It's
mic lines are
go
closed.
5 ways deep.
I don't think you can chain them indefinitely because of the 0 to 1 RTT, right? This goes from 0 RTT to 1 RTT. And I don't think you can chain that indefinitely.
Yeah.
I think we're getting cut off.
Last one.
Okay.
Quick.
Mike Bishop. So going back to the question of whether it's valuable to be able to get out of the way of decryption, we had presentations at the HTTP workshop in Münster from devs on both Varnish and HA Proxy saying that the requirement to do encryption on both sides for HTTP2 was killing the perf. So I think there is value in the gateway being able to get out very early in the conversation if these are two separate machines.
Thank you.
Quinn?
So for the future communication between the client and the hidden server, is it possible to do zero RTT if you can add more? Because after that first communication, you got the hidden servers share. So then in the future, possibly you can do zero RTT by adding more data encrypted with the hidden servers share.
This goes into the encrypted extensions that Jana was talking about. And you could conceivably, but I don't want to tie this to that level of having 3 sets of keys that are involved instead of 2. I mean,
okay, but
the point is that this bit here can't use a server config that is this guy's server config because this guy needs to be able to decrypt
but
it.
it could be like 2 layers. So down there you have data encrypted with the hidden servers share. And
Right,
then at the time you do you can do zero RTT. So that means the first time one RTT is just one time. In theory.
I think we're out of time. So I think what we need to have, this seems promising, but I think we still not everybody's understanding it. Then maybe that's just me, I don't know. But
we also didn't get to the we didn't get to the so what we got to was the argument that real SNI is something that's valuable for at the very least the co-tenanted case and maybe for this case, and we didn't get to the priming question. Priming is only needed for this. Priming is not necessarily needed for the co-tenanted case.
Does priming involve the protocol, or is it outside the protocol?
It would be nice to be able to prime in band.
Okay.
But
all right. So I think
But I mean, I think you can get this to work without priming in band. The only thing I would like to say is if we want to preserve the ability to prime in band, I see no way to do it unless the server is allowed to send something send an extension without the client having sent the extension in the past.
Okay. All right. Well, so let's do this. Let's you guys get together, keep working on this, and we can have a phone interim at some point when so.
Yeah, sorry. You guys do your design team thingy, go off and do it. Then we can set up like an interim. We need I don't know, it's like a week's notice or something, and then we get on the phone for 2 hours and do it again. And you can explain what you think that's better with slides that are better hung together or whatever it is. Okay. So we can do that. So I'm shooting for mid-December sometime, right? So when we should bring or earlier. Yeah.
So is this something that needs to go into the core draft, or can we get away with
this is the driving thing why we keep talking about this, right? Is this going in 1.3 or not? Is really the
so there is one small piece that we could put in, which is the encrypted extensions in zero RTT, and is that all you need as a bootstrap into this?
So we do definitely need encrypted extensions in zero RTT.
Right.
I think that for in-band priming, I think we would need the ability for a server to send an extension that the client has not sent. Sorry?
Yeah.
I think this is a conversation, a perfect conversation for bits and bytes over beer. Yeah. Those that are interested, find them. Blue sheets, please. Thank you. Thank you all for sitting through 4.5 hours of us. Yeah.